So today we're going to be building a proof of concept application um, for an integration service. Um, and so what do we want it to accomplish? We want to be able to connect outside services via a single interface or service and be able to build all sorts of integrations in a streaming type fashion. Um, so design-wise, what is this going to look like? We're going to have the thing, the data source that we are collecting from. In this case, we'll just call it a sink, and we want it to end up somewhere. And we are going to call that the source. Now, a lot of these applications already exist, and they are batch-based. And so what that means is that based on like some sort of timer or cron job, um, at certain intervals, like the sync job is going to grab data from your sync. It's going to push it directly to your source. Um, Now, there's a couple of issues with this type of system. A, they're not real time. Um, uh, uh, Not real time. So you have customers or users waiting on data to sync. Um, so that leads to bad customer experience, as well as having to design other systems around this waiting nature, providing SLAs and stuff uh, that revolve around um, jobs being run like on a timer. Other issues is that persistence is somewhat lacking of these jobs, um, uh, and I'll go into that. Um, so let's say you run a job and it's able to pull data from your sync, but halfway through it breaks. The data doesn't end up in the source. So what you have to do is generally restart your application and rerun the whole entire job. This generally leads to like wasted resources, because again, you're going back to the sync, or you're like where your data is being stored from, refetching it, and then having to perform the whole job over again. This is not a great pattern. Also, it relies on can rely on like human operators to verify if, hey, like, has a certain job run, was it stuck, etc. And in cases where this data is very useful or critical, you're spending a lot of operator hours going in there, making sure the jobs are running. Something crashed. Why did it crash? A lot of issues. So this works. Very good pattern. However, I think we can make it better. And the way we're going to do that is via a stream based architecture. So in short, we're again going to have our sync and our source. But along the way, we are going to break this, get data in smaller increments, and store it in something called a like an event queue or an event broker. What the power of this provides for us is that instead of relying on a timer to go ahead and process data that we want, we can go ahead and do that on the fly. So as let's say a service goes ahead and sends us a message via, a post request. It'll end up in our sink. The sink will push it to our event broker, and then we'll have some sort of method or functions or application that can then directly go and push that to the source. This is extremely powerful. Again, this allows for real-time performance or near real-time. To be clear, we are limited by certain hardware as well as like the speed of light. And one of the other big cool tools of this is this here provides persistence. So let's say our application breaks, our integration application breaks. Well, the events are still loaded into the broker, and as soon as the application restarts, it can just reboot, reconsume the messages, and go ahead and push that to their destination. So what are the cons of an architecture like this? Well, generally it's a little bit more complex. We're thinking about things in terms of adding this, now third layer, this third piece to our architecture. And it requires us to think differently. Generally, beforehand, you could just think about one job going and collecting the data and just sending it off to the destination. Here, what we want to do is we want to be able to collect our data, push it into an event broker, and then that event broker, we can even we can do things like cool on the fly, push it into another topic or queue, transform it, send it to multiple sources, etc. So this is a lot more powerful of an abstraction, but you just need to be able to think of things in terms of streaming and stream-based architecture. So now that we have discussed some of these trade-offs, let's just go ahead and try to code this thing up. So I'm going to be developing this in Python initially, just so I can get a proof of concept out the door. What I realize is that I will probably have to rewrite this a couple of times to actually make a fully functioning, like a good version of this. And I may do that in another language down the line, maybe even integrate it directly into LucidMQ, which is going to be providing our message broker and persistence. Quick note on that. Go ahead and check this out on GitHub. It is a rather small repository, and it's going to serve as the backbone for this library or this application. Very simple message queue, similar to Kafka or RabbitMQ, written in Rust, and it's going to be developed around this specific use case that I just identified before. So it might not be as general purpose as some of these other ones, but I think we can squeeze out a lot more performance and a lot smoother feeling down the line once we use this library. So I already started by creating a couple of different classes, testing them around. And so the first use case that I want to design around is, let's say you have an application. Now we have a sink, or like our source data, like our incoming data is coming from like a webhook request. So we need to be able to ingest that webhook request and then put it in our event broker and then be able to consume it. And so the destination, the most basic destination in this case, is going ahead and sending out another request. So we will send a HTTP post request. From here. This is probably the most basic as well as applicable of these type of connections. So we're going to kind of design around this use case. Once we have a kind of framework for setting this up, then we can add different syncs and sources so you can mix and match and push them to different things. So let's go ahead and look at what I already have written. So we have a class called a connector, and this connector, it handles, this is going to be like orchestrating this whole part of the equation. So it's going to have a reference to a sink and a source, and this will be where all that metadata is stored about what is connecting to what. We're also going to need a little bit of fancy logic to be able to tell our application when to go and grab things, where to grab things, and so that's where some of these helper methods are going to come into place. So if we go ahead and look at the sink next, this is where the input data is coming through. So we are going to have two different types of sinks, push and pull. So for our webhook example, this is push-based. So when a post request is sent, that's being pushed to us. We don't need to go out and fetch that data. And this is kind of the best case scenario. However, there will be some sources where you will have to go and pull for it, go and grab that data yourself. And so we have a generic class called a sink, and then we will add subclasses of sinks that will be specific to whatever methods or wherever we're fetching that data from. And then our last piece is a source. So this is where the data is going to end up at the end of this all, destination-wise. Again, very similar to sync. We have a source class, parent class, child class of HTTP request, and it just goes ahead and sends a request. Pretty simple stuff for this. And so now what we need to do is be able to connect it all together. So in our main here, what we're doing is we have a little Flask application or server that is going to serve, well, let's just go through it. Instead of connecting to a database to store a lot of this metadata at the moment, we're just going to run this in memory. All of our connectors are going to sit here. Active connectors are going to sit in here. And those are going to be able to be modified via a HTTP REST API. So see here we have an add connector API, parses some JSON, and then it's able to go ahead and create a connector, add that connector to our data store. Great, so that's going to be our input for the user. Now, we have a couple of different issues now. So one is that our source, we need to be able to constantly look for new messages that populate our queue when our sources are running. So we're going to need to probably spin off new threads and do that here. So I'm going to go ahead and change the name of this. As well as this is going to get refactored when we implement the new webhook logic. So this is our starting point. A lot of what we're going to be doing is interacting with LucidMQ pre-built Python library. It's pretty extensively tested, and I think it'll provide a good base for our demo application here. So let's go ahead and get this thing to work. So the first issue I know of is that we have our webhook. And so when a new user wants to add a webhook, they're going to send this connector request. Right now it only accepts webhook and HTTP request for the sink and the source respectively. But registering a webhook is somewhat difficult of an endeavor. So if we look here, what we want this to do is when you create this connector request and it has the type webhook, we want to be able to generate a new route on the fly. And so that new route will be able to accept all incoming post requests and then be able to push it into our topic. Let's see. So I had this working here, and this actually works, but there was a problem with it. So I'll go ahead and run this, and then we'll look into the problem. So we're going to go ahead and run our message broker, and then we're going to go ahead and run our server. This is probably going to break. Okay, so if we go ahead and I'm just going to spin up a Postman instance here. And then we are going to want to send this to, so this is our actual route. Not really named particularly well, but what this should do is when we send any sort of body of JSON, it's just going to produce that to our topic. And wow, it's off to a good start. It's because this takes 3. It definitely didn't take 3. Okay, let's go ahead and send the request again. Something else is fucked up. Dummy funk. Oh, that's because this is not a dummy function. This is going to be test. Sorry. So if we look at our webhook method here, or our class, we provided a name and a topic. This topic is the topic that we're going to produce to in LucidMQ. This name is going to be like the end of the route. So if we look here, we have this. It's the route is just called test. So it's not dummy phone. It's just test. So if we go ahead and send this request, it doesn't work. And why is that? That is because, okay, this is our big issue here. We are running, so Flask doesn't allow for any sort of modification of this app instance after a request has been sent. So we will need to fix that. Get rid of this timeout state. Because I did have this working earlier. And then success is not equal to true. Okay, so our topic does not exist. Topic 1 does not exist. Okay, that makes sense because in this instance, we're not creating a topic, so it's going to go ahead and blow up. This is where our topic management existed before, but we don't necessarily have that anymore. So let me go ahead and spin up a new topic, I guess. So I'm going to go ahead and use the CLI. It should just give me some cool information. Has to compile first. And cool. Here I'm going to run connect localhost, and the port is 969. Cool. Let me just use the normal address. Oh, where is it actually sitting at? Yeah, 127.0.0.1. 0.0.1. Okay, cool. So topic 1. Cool. So we got a response. It's true. Our topic is created now. So let's go ahead and try this again. Alright, hopefully our routes are all created. Alright, so now our message was produced here. Awesome. It consumed the message, sent a request. Cool. So that's a very very incomplete example of how this is going to work. Now we're going to need to put in the connector logic to be able to orchestrate all this. So instead of me going in there and creating this topic, this is going to handle all that for us, as well as we need to solve our problem about adding routes on the fly. So cool. So now that we have this demo, we can go ahead and use some of this code to go ahead and update this. So the first thing I want to do is, I had this backwards, but what we want to do is be able to call in register on our webhook object, and then this is going to be able to, where did I put it? This would be able to do what we're doing here and add a URL rule for our application. So let's go ahead and write that. Okay. So given an app, all we want to do is be able to okay. And as we said earlier, there's going to be self.route endpoint is going to be self.route, and we're going to need to create a view function. We already have that here. All it does is whenever we receive a request, we're just going to get the JSON. We're going to call the function that we pass in here. So this is going to be self.produce function on this input, and then we're going to return some sort of valid response. So this is pretty straightforward. However, this is going to break because we don't need this now. So let's see, what did I want to run? So now in our connector, what do we want to do? Think here. So during the connection handler, we're going to hit run collector. So on the collector, yeah, we'll keep this logic. We only want to register it once, so we have some sort of flag letting us know if it's registered or not. If it's a push, then we know it's a webhook. This will probably get changed in the future, but let's go ahead and just register. And then here, this will need to be app. And app in this case refers to our Flask like instance or object. And then this is going to be app. Okay, so if we go ahead and run this, it's going to break. Let me just exit this. Sweet. Let me just start fresh here. I'm just going to remove the log. We don't have any messages left in there. I need to run this. Okay. In-memory data store. This is because this thing is messed up. We're just going to go ahead and replace this with connector data store. Sweet. Save this. Okay. Cool. This is working. So now, what we want to do is we're going to make our connector request. This just says, well, what topic are these things going to be producing to and consuming from, and then what the types are. So we know our sync is going to be a webhook, and our source is going to be a request, HTTP request. Let's go ahead and run this. So now we know it's created, and then during this run connector, you see we get this issue here with Flask. And so this is the setup method, can no longer be called on application. It already handled its first request. So this is a problem. Flask is not dynamic, right? It's going to basically blow up. We have to define all the routes up front that we want to be able to consume from. And that's kind of against the design of this application. So we need to get a little more creative. So as you see here, this basically describes what we want to do is not correct. Awesome. So now, there's a way around this, and that is to, when we add a webhook route, what we can do is we can restart the Flask application with our new route. So then it picks up the route. And I'm not talking manually going in the terminal and stopping it and then restarting it. We're talking more about adding some sort of smart method that would detect when a change is required to restart and then go ahead and run that restart logic. So I found this This like little sample piece here. It's written a long time ago, but I think this can solve our issue for the time being. So let's go ahead and implement this. I'm going to go ahead and make this smaller. We don't need this. We don't need this. Okay. All right. So we have Flask. So here we wrap our app in our own custom class object, and then this is what we're actually using instead of just using this directly. So I'm going to go ahead and implement that. So what is run simple? Run simple is a it's a method provided by something else. Starts the God damn it. Just starts a WSGI application. Includes a reloader method for support. Cool. Okay. So I guess we don't have to write a ton of stuff. So the first thing we're going to do is takes in an object. It's kind of weird. Takes a create app. I think that's just a method. So self.create app is equal to create app. Self.app is equal to okay, we just call create app. Def get application. So we have a reference to a global variable. So this lets us know, as the name implies, if we need to reload or not. So we're going to go ahead and call the create app, and then we're going to set to reload equal to false. What is call? And then this is going to return app. I don't really know what that is. Okay. Python has it's a built-in method that we're going to override. And enables Python. Okay. Enables Python programs to write classes where this behaves like the function. Okay. So, okay. So we want our object to be able to be called like a function. So that's why we implement this call. All right, that makes sense. If we look in this thing, it's just calling it's just going to call this method. It's going to recall. What the fuck? Oh, whatever. Okay, we need our instance variables. And start response. Okay, reloader. Okay, so then so in this case, the reload is being called on a route. In our case, we're going to have some other type of logic that's going to do that. To reload is equal to false. Okay. 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 All right. So now we're going to go ahead and keep this here. We don't need this anymore. Okay, so then instead of at being run, we're going to do run simple. This is just going to be host name, port, app, we're just going to set this to false. This is also going to be false. So we're using I don't even know what this does. Should the exception evaluation feature be enabled? Sure. All right. Okay, so now we are going to be starting our application like this. Application is equal to app reloader. Let's see, so we need to provide our things in here. Okay. Or we just serve our index route. I need this thread. Okay, let's see what it does. Okay, so it works. Now we need to add all of this crazy logic. This thing's kind of useless. I do want this eventually. God damn it. Okay. Um, all right. Now that this crap is cleaned up, you can go ahead and try and start this thread. But we do know that connection handler now needs a reference or a way to call app reloader. So, right, because if we look at our example over here, it looks at to reload, Um, let's see. Hmm. Oh, okay. So it sets to reload as true, which is great. Right. So we need to be able to pass this in. So run connector will take a reference to you will need to be able to take a reference to get app. Because I assume what we want to do is we need to be able to run get app. We need to be able to run this. Okay, so now we go to connector. I don't think it's explicitly calling get app though. It's only run one time in this application reloader thing. All right, let's go ahead and run the connector. Mm-hmm. To reload. Okay. Mm-hmm. Fuck, dude. How am I gonna do this? I don't understand. How does this thing work? Could do that. Could reload the app on every connector. I don't need this. What the fuck? Alright, makes sense. I don't even need this. We don't even need any of that. Reload. Reloaded. Okay. Okay. Flask object has no thing. Create app. Right. Trying to reload is equal to false. Da, 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 da. Okay, so we want to actually just, god damn it, so much junk in this file. Okay, I'm also going to do this date time thing. And a date time. Okay. Okay, so we're going to go ahead and run this request. Just for debugging purposes. Okay, started then. Now let's call reload. Reloaded. Okay. Creating a new instance. Okay. That's sick. So it's after reload, then the new instance will be created. Okay. So that's like on request, I guess. So here's what we're going to do. We're going to add this logic in our getSync method. So this will just tell us we need to reload this crap. Okay. That's what we're going to do. Every time we do a reload of our handler, we are actually going to do this. This is going to pass in our app instance. What the fuck, dude? Seems to die. Okay, so run connector. So here in our run connector, we are going to have app, register app, because we are passing in our application instance. Yep, our Flask application instance. This is going to go ahead and run the register over here. Sweet. Let's see if this actually does anything that we want it to do. Okay, let's go ahead and run we're going to create a new connector instance. Success. Now I want this to oh, I think it's called test route. Goddamn. No, dude, come on. Okay. Okay. So we're going to go ahead and register this. This should all be good. And it needs a request to come through. So let's go ahead and just reload it or something. Registering test route. I feel like we're so close. All right, here's what we're gonna do. I think what's happening is when we do a run connector, we need to we're going to return our instance of this. See, because it's not really going anywhere. Okay, we're registering the route. Sweet, the message is returned. Ah, come on. Hmm. Awesome. See, test route. It's here. You motherfucker. Oh, it's because it's a GET request. What? Okay, so the route's registered. It's just fucked up. So it's here. It just doesn't do anything, which is ridiculous. I don't get it. Ah, come on. Doesn't make sense, dude. Add app URL. Hook.produce function. Okay. See, endpoint is what? Let's look at these parameters here. Endpoint. I think this is the problem. Okay, that makes sense. Like, that's not a real thing. View functions. What if I just do none? Okay, we're going to go ahead and register. Send this stupid little request. Post this. Okay, view func. What is view func? Hmm. Hmm. So the route's registered. It's like working, kind of. Mhm. Come on. Okay. Let's like not do this for now. And we don't need this. This is just going to be like this. God damn it. This is brutal. Alright. Well, I need to go and do something else, so finish this later.